Write out an arithmetic sequence with 5 terms and a common difference of -5. Then give the general formula. 5 terms, n is 5. The common difference right here is -5. We're adding -5 and adding -5 4 times to get to the 5th term. Let's just start with any number. How about a 2? If we start with 2 and jump to the next term, we'd end up with a -3. Because positive 2 plus a -5 gives us -3. From -3, add another -5, and we get -8. Add another -5, we get -13. And the final last term would be -18. Now we're asked to write the general formula. In order to find the general formula, let's list what we know. The first term in this sequence is a 2. The last term we can state is t of 5 is -18. The number of terms is 5, and the d value is -5. Now to write the general form, we use the first term. We don't use the t of 5. We don't use the n value here, but we need the d value because we want to be able to plug in any value for n and solve. Now we will always have a 2 in the pattern, and the n is a variable and the d is constant, stays the same, and this last value would change. We have 2, and then distribute the -5 times n, and the -5 times -1 is a positive 5. Write your variable first, and then combine 2 plus 5 is a 7. The general formula for my sequence is t of n equals -5n plus 7. Let's see what would happen if you started with a different first term. Let's start with a 1. So if we added a -5 each time, the general term would be t of n equals the first term plus n minus 1 times your d, common difference of -5, and distributing this -5 through, we can write it as a negative. We have -5n plus 5 equals -5n plus 6 for the general term. So it's a little bit different. One more. What would happen if I started, let's say I started with a -3. So -3 here was the second term. Let's say my pattern I wanted to write the general form would start with a -3. What would that look like? Each time we add a -5, t of n equals -3 plus n minus 1 times the -5. T of n equals -3 minus 5n plus 5, and t of n equals -5n plus 2. 3 possibilities here. Yours might look different. Good job. Is the following an arithmetic sequence? If yes, find a formula for the general term and use it to determine the 100th term. Show your thinking. All right, so first off, we need to prove that D is the same for every jump. And in fact, you have to show each one. So let's label them. T of 1, T of 2, T of 3, T of 4, and T of 5. And we'll have to check every single one. D is equal to T of 2 minus T of 1. So we know we're going this way to check it with a subtraction. Negative 1/2, subtract 1/4. We need a common denominator, and we'll go for 4. So negative 2/4 subtract 1/4 gives us, it looks like this, negative 2/4 combining with negative 1/4 is a negative 3/4. And D is equal to T of 3 minus T of 2. So now we're checking this one. Negative 5/4 subtract, I know T of 2 was the same as negative 2/4. We have a negative 1 times a negative 2. So we have a negative 5/4 plus 2/4, which is negative 3/4. So far we have an arithmetic sequence, but we need to keep checking. So the next one we'll do is D is equal to T of 4 minus T of 3. T of 4 is negative 2. Subtract negative 5/4. So we're going to get a common denominator here of 4. So what do I do here? I times by 4, so I have to times the top by 4, negative 8. Now is negative 8 divided by 4 the same as negative 2? Yes, so I know I did it right. And then we have a negative times a negative, which makes a positive 5/4. We have D is equal to negative 3/4. So it's looking like it's arithmetic, but I have to check the very last one. And we'll check this one here. D is equal to T of 5 minus T of 4. Negative 11/4. Take away negative 2, which we said was negative 8/4. And it turns out we get negative 11/4 plus 8/4, which in fact is negative 3/4. So we know we have an arithmetic sequence because all of the D's are the same. Now it says, if yes, find a formula for the general term. Let's do that then. D is negative 3/4. T of 1 was 1/4. What else do we know? Well, in the general formula, we don't know n, and we don't know the last term. So the general formula comes from the original formula. So we'll plug in 1/4 plus, we don't know n, it changes all the time, and then the D is negative 3/4. We need to distribute, so we have 1/4 plus, now it's negative 3/4 times n, so really what I should do is, I know it's a plus, but it makes more sense if I write it as a negative 3/4 n, and then negative times negative is a positive 3/4. Now we'll put the n first, so negative 3/4 n, And then we'll add 1/4 plus 3/4 is 4/4. Therefore, the general formula would be -3/4 n plus 1.